Good morning, students! Welcome to our fun-filled episode today. I am Sir Jethro, your teacher for Science 9. Today's topic is all about the other non-Mendelian patterns of inheritance. Are you excited? Now, take out your notes and pen as we discuss our lesson. At the end of the lesson, you are expected to first, identify the patterns of non-Mendelian inheritance. Second, describe and differentiate the sex-limited traits and sex-influenced traits. And last, predict the possible genotype and phenotype of offspring by using a Punnett square. Now, I want you to answer the let's try portion of your module. Circle the letter of the correct answer. Number 1. Which of the following is an example of sex-influenced trait? A. Baldness. B. Deafness. C. Clone genes. And D. Tongue rolling. The correct answer is letter A. Number 2. Which of the following is an example of sex-limited trait? A. Lactating male cow. B. Lactating female cow. C. Fattening male cow. And letter D. Fattening female cow. The correct answer is letter B. Number 3. Patterned baldness is a sex-influenced trait more expressed in a male. If B positive is normal allele, making non-bald phenotype, and B is mutant, leading to a bald phenotype, for a cross between a bald mother and normal father, what is the probability of a bald son? A. 0%. B. 25%. C. 50%. Letter D. 100%. The correct answer is letter D. 100%. Number 4. If A is a sex-influenced trait that is more expressed in males, then which of the following is false? A. The gene is autosomal. B. No female will express the gene. Letter C. Heterozygous female will not express this gene. And letter D. Only male having a homozygous recessive form of this gene will not express it. The correct answer is letter B. Number 5. What pattern of non-Mendelian inheritance is expressed only in one gender? A. Sex-limited. B. Y-link. C. Sex-influenced. And letter D. X-link. The correct answer is letter A. Sex-limited. Have you got all the answers correct? If yes, congratulations, but if not, you still have a chance to get a perfect score in our next activities. Now, let us move to our lesson. The inheritance of characteristics is not always as simple as it is for the characteristics that Mendel studied in pea plants. Geneticists now know that inheritance is often more complicated than the simple patterns of dominant and recessive allele. Traits that follow non-Mendelian pattern of inheritance do not segregate in accordance with Mendel's law. I want you to look at these definitions before we dig deep down to our lesson. First, autosomal. It means that the gene in question is located on one of the numbered or non-sex chromosomes. And gene, it is the basic physical and functional unit of heredity. Genes are made up of DNA. Sex-limited genes are those which produce characteristics that are expressed in only one of the sexes. They often confused with sex-linked genes but are entirely different in their mode of inheritance. Sex-limited genes are generally autosomal. The genes for these traits behave exactly the same way that any autosomal gene behaves. The difference here comes in the expression of the genes and the phenotype of the individual. Sex-limited traits are expressed in only one gender. In cattle, for example, lactation is expressed in females, but never in males. Both of them, however, possess a gene pair for lactation. Take a look at table number 1. It shows the genotypes and phenotypes of the gene for lactation. The gene for lactation, or the capital letter L, is dominant over the non-lactating gene, or the small letter L. These genes are carried by both males and females, but is only expressed in females. In females, if at least one dominant gene is present, that female will produce milk. But if both dominant genes are absent, she will not lactate. In males, on the other hand, if both dominant genes for lactation are present, he still will not lactate because the trait is sex-limited. The beard in man is another example of sex-limited trait. Both the male and female carry all the genes necessary to produce a beard, but only man shows the trait. To express the gene for beard, we use the capital letter B for with beard and small letter b for without beard. Now, let's move to sex-influenced trait. Sex-influenced trait is a trait controlled by a pair of alleles found on the autosomal chromosomes from pairs 1 to 22. Its phenotypic expression is influenced by the presence of certain hormones such as estrogen, progesterone, and testosterone. Sex-influenced traits can be observed in both sexes, but will vary in the degree of phenotypic expression. Pattern baldness in humans is an example of sex-influenced trait, though this condition is not restricted to males. This is highly influenced by the hormone testosterone. All humans have testosterone, but males have much higher levels of this hormone than females do. The result is that, in males, the baldness allele behaves like a dominant allele, while in females, it behaves like a recessive allele. The gene for this trait has two alleles, bald and non-bald. To express the gene for bald, we use the capital letter B and small letter b for non-bald. If you look at the heterozygous gene pair for baldness, males express baldness while females do not. Baldness may be expressed in females, but it occurs more frequently in males. Such trait is sex-influenced because of a substance that is not produced equally in males and females. Another example of sex-influenced trait is Heberden's nodes, or the bony excrescences on fingers. To represent the gene for this trait, capital letter R is used to represent the allele for Heberden's nodes, and small letter r is used to represent the allele for normal. The trait is dominant in females, while it is recessive in males. If only one allele from the pair is for Heberden's nodes, the phenotypic expression of female is she has Heberden's node, but as for male, he has no Heberden's node. Now that you have learned how genes for those with Heberden's node and without Heberden's node are represented, You can easily identify the phenotypes for different genotypes in this activity. Directions. Identify the possible phenotype for each genotype. Choose your answer from the following. First, male with Heberden's node. Second, female with Heberden's node. Third, male without Heberden's node. And last, female without Heberden's node. For number 1, we have the homozygous dominant female. The correct answer is female with Heberden's node. Second, we have heterozygous female. The correct answer is female with Heberden's node. And third, we have homozygous recessive female. The correct answer is female without Heberden's node. Fourth, we have homozygous dominant male. The correct answer is male with Heberden's node. And fifth, we have heterozygous male. The correct answer is male without Heberden's node. And last number, we have homozygous recessive male. The correct answer is male without Heberden's node. Now, let's move to your next activity. Given the problem, complete the Punnett square to predict the possible genotype and phenotype of their offspring. Here's the problem. In birds, the 6 chromosomes are called Z and W. In the male is homogametic, ZZ. In the female is heterogametic, ZW. A peacock is a male peafowl. A peahen is a female peafowl. The fan-like tail feather in peacocks is never expressed in peahens. To represent the gene for fan-tail feather, capital letter F is used, while small letter f is used to represent the gene for without fan-tail feather. Illustrate using a Punnett square when a peacock with fan-like feather mated with a peahen without a fan-like feather. After that, please answer the guide questions. Number 1. What are the possible genotypes of their offspring? Number 2. What are the possible phenotypes of their offspring? And last, what genotypes do not express fan-like tail feather? Now, for your last activity, I want you to answer the Let's Sum It Up. Directions. Read the statements below. Write true in the space provided before the number if the statement is right, and if it's wrong, write false. Number 1. Sex-limited is autosomal. The correct answer is true. Number 2. The genes for sex-limited traits are found in male. The correct answer is false. Number 3. Sex-limited traits are only expressed in one sex. The correct answer is true. Number 4. Hormonal imbalance cannot affect the expression of the trait. The correct answer is false. Number 5. The beard in man is an example of sex-limited trait. The correct answer is true. Number 6. Heberden's nodes is an example of sex-influenced trait. The correct answer is true. Number 7. Heberden's nodes is dominant in females but is recessive in males. The correct answer is true. Number 8. Pattern baldness is an example of sex-influenced trait. The correct answer is true. Number 9. Baldness is influenced by hormone progesterone. The correct answer is false. And last number, female cannot produce milk if she only has one gene pair for lactation. The correct answer is false. Now, let us try to assess what you have learned in our session today. For number 1, if A is a sex-influenced trait that is more expressed in males, then which of the following is false? Letter A. The gene is autosomal. Letter B. No female will express the gene. Letter C. Heterozygous female will not express this gene. And letter D. Only male with a homozygous recessive form of this gene will not express it. The correct answer is letter B. No female will express the gene. Number 2. Which of the following non-Mendelian pattern of inheritance is autosomal? A. Sex-influenced. B. Sex-limited. C. Both A and B. And letter D. Homologous. The correct answer is letter A. Third, which of the following trait can be expressed by both male and female? A. Fan-like tail feather of a peafowl. Letter B. Heberden's node. Letter C. Lactation. And letter D. Both A and B. The correct answer is letter B. Heberden's node. Number 4. The mother has pattern baldness and the father is not bald. What is the genotype of the mother? Letter A. Heterozygous female. Letter B. Homozygous dominant female. Letter C. Homozygous recessive female. And letter D. Heterozygous male. The correct answer is letter A. Number 5. What is the genotype of the father? A. Homozygous dominant male. B. Heterozygous male. C. Homozygous recessive male. And letter D, heterozygous female. The correct answer is letter C. Now, we are done with our session today. See you in our next video. Stay safe and thank you for watching.